right, go ahead. You guys quiet.
Okay, so H naught is mu1 equals mu2.
Great.
And then H1 is mu1 does not equal mu2.
How do you know it's different? How do you know it's that?
Because in the claim it says that the mean weight of males is different than the mean weight of females.
Right, different, not equal to.
Right. And that's a claim. And then step 2, the degrees freedom is 7 because you're going to take the smaller
Smaller n?
sample size, yeah. And so that gives you a critical value of plus or minus 2.365. And then step 3, plug in
See how she shaded?
Oh, yeah,
Right, positive, negative. Great, two-tailed, positive, negative.
correct. And step 3, just plug in all the x1, which is 123, x2, or x bar 2, which is 116 over all those numbers.
Yeah, that's fine.
And then which gives you the test stat of 2.268, which is not in the shaded area. So you do not reject H naught.
Good. Step 4, yeah.
And then step 5, not enough evidence to support the claim that the mean weight of males is different from the mean weight of females.
So again, remember that your two-tailed when your claim is equals or not equals. Your one-tailed when your claim is less than left-tailed or when your claim is greater than right-tailed. Okay.
Question.
Yes, question.
S1 and S2 on it.
Yeah.
Is it, I put down 3.3.
Oh. It says 8 ounces. Standard deviation is 8 ounces. And the standard deviation of the sample is 5 ounces.
Oh.
3.3 was the last one.
You're looking
That
at
was good, the last one.
Okay. Good deal. All right.
I got
Great.
2.27.
So this is correct. Yeah, if you rounded 2.27, it's fine. Okay, everybody all good?
Kill that.
Incidentally, these will, remember, you guys know all of these are on Canvas, right? Under BoardWork PDFs. The videotapes, I finally got them working. The first 3 I did for both classes, I did the time stamp thing, right? So we had like 1 frame for every 2 seconds, which was ridiculous. You can't see anything. But I have them. I figured out the last 2 days took me to figure out how to like edit them to make them smaller and upload them. So they're last classes are all on YouTube. This class will be on YouTube. But since they're not closed captioned, I can't post a link on Canvas. If you email me, I can email you the link to one of the videos, and then you can subscribe to my channel, and then you can see my channel. Whatever. I was like, I don't want to have it, but there's no other way of doing it easy, right? So then you can look at all of them. Yeah. If it's annoying, it should give you a lot of commercials. Because it shouldn't be that.
And that's awesome.
Right.
Wait, have we gone on break?
These guys is very similar. It's going to be x bar 1 minus x bar 2 plus or minus your error, or this is your error. But go ahead and go to this page, right? And you can leave the top part, but just put an X through just these 2 problem areas. We're not going to do those. Right? No worries. We're going to skip that. Right. So this part here where it says, you guys play it. I'm only going to say it one more time, and that's it. Confidence interval estimates, U1 minus U2. The example and lab problem 5, we're not going to do those. So you put little X's through those. Okay. Now, I want to talk about the project. All right. You guys got a little lucky. I decided, for whatever reason, I only assigned 1 hypothesis test, not a proportion, only a mean, because I was not paying attention. Thank you. But, so it's just a mean. So You have 4 questions you picked in the beginning, you took a picture of. 2 of them are means. 1 of them you did in project 6, right? And for that one, you went into your spreadsheet and you did equals average and you picked all your data to find the average, equals STDev and you picked all your data to find the standard deviation. Use that one because then you'll have your mean and your standard deviation. Alright, so someone tell me one that they used.
How tall are you?
How tall are you? Great. So how tall are you?
Second one.
Yep. So pick whatever your question was, and then you run along it, and look, you can either claim that the average height is over 5'10", over 70 inches, under 70 inches, or equal to 70 inches. You pick one to be your claim. I don't care. You can either claim that it's more than 70 inches, less than 70 inches, or equal to 70 inches. And then you're going to do a hypothesis test based upon that claim. Someone give me another one that they did. Age, great, so the top one. So then you're going to pick for your claim either the average age is less than 25, equal to 25, or greater than 25. I don't care, but pick one of those to be your claim. Do you guys see what I'm saying? Good?
Do you want us to use the exact same question, or should we use
Yes.
the other question?
You should use the exact same question because you already had the mean and standard deviation for that question.
Alright.
You see what I'm saying?
Yes.
Great. If you didn't do it last time, then do it now if you didn't do it correctly last time because you don't want to be totally off of where everybody else is on this. And then you're going to state your claim about your chosen parameters. So look at the top of the page and you're going to kind of see, so it might be something like this. Those who know LPC community college students work an average of less than 25 hours a week. Or you might say if yours was age, those who know LPC community college students have an average age of less than 25. Or have an average height of more than 70 inches. Whatever you pick for your claim. Okay? Carla.
So part 7, we're only doing a quantitative question?
You're going to pick yes. It's a mean.
We're not doing the, okay.
You got lucky. You're only going to do quantitative because I forgot to include the qualitative. So you're only going to do a mean.
Okay.
Okay. So it's the one that you picked that you already found the standard deviation and mean for, the average for. And then after you write that down, and you can neatly write it or type it, I don't care. And then you're going to state what distribution you're going to use. Is it going to be a z distribution or a t distribution? It's a mean, so it should be a blank. You should know that. Okay? State whether or not what your requirements are that you fulfill them. So you'd say, my data fulfills the requirements because, and then go back to the project part 6 and find the ones for mean, because this is a mean, and write out what those are, right? It's the fact that our sample size is greater than 30. That's the one you're going to use, right? And then step D, conduct a hypothesis test using the 5, alpha equals 0.5, using the 5 steps that we've gone over in class. Okay? What is, for degrees of freedom, 160, is that closer to 120 or a billion? 120. So you should use your sample, you should go down, drop your degrees of freedom down to the 120. Everybody understand that? Okay. And then do your 5 steps. Okay. Cool. That is due on Tuesday. You can turn it in late on Thursday for full credit. But Tuesday's your chance to get all of your, I'll get my homework problems sorted out. All right, now we're going to get to the last part.
And I have a dog.
Dependent samples. Let's get a reader. Amin, go ahead and read.
Dependent samples. Example, match pairs of heights of U.S. presidents and the heights of their main opponents. Since there is a relationship as a basis for matching the pairs of data, this data consists of dependent samples.
Great. So guys, this can be really, really simple. If you guys focus for the next 3 minutes, it'll be super simple. If you don't, it's going to be totally confusing and you have no idea what to do. Dependent samples are when they're in matched pairs. They go together. So in other words, this is the height of a president and his opponent. This is the height of another president and his opponent. Height of another president and his opponent. They go together. So this 189 goes with that 170. That 189 cannot go with this 175. That's somebody else's opponent. You guys understand what I'm saying? These are matched up. They're pairs that go together. All you do when you get these matched pairs, how do you know it's dependent? Because they'll be in matched up pairs like that, where they're clearly labeled as this and that, and you know that they go together. So here, you're just going to subtract them. Figure out which one you want to use for the first one. I want this one to be my mu1, this to be my mu2. They're always going to be means, numbers, because you can't subtract yeses and nos, right? And you're going to subtract them. So I'm going to subtract them 19, negative 12, 8, 0, 1. These are what we call my differences. Now we're going to run just a regular one sample t-test, one sample regular hypothesis test on this sample here. We're going to ignore the original data because we found the differences. We don't need them anymore. Now it's just, this is our data. It's just a one sample t-test on this one sample, this one bit of data. Make sense? So then it's super easy. It's just like we did in chapter 8. One sample. Pretty really straightforward. Here's the notation. How about Kevin? You want to read for us?
So notation for dependent samples, D equals individual difference between the two values of a single matched pair.
UD?
UD, mean value of the difference is D for the population of all matched pairs of data. D bar equals mean value of the difference in D for the pair of sample data.
Right, so this is really kind of the same thing as X bar sub D, right? You kind of think of it like that. It's just the average of all those little D's that we just found. Keep going.
Standard deviation of D equals standard deviation of the differences D for the paired sample data, and N equals number of pairs sample data.
Good. So there's some basic requirements. The sample data have to be dependent. In other words, they have to go together. So in other words, if I pick a group to be my sample, like I picked you guys, this row to be my sample, and I'm going to use your left arm, then for the second sample, I have to use you same people. I can't pick other people. So if I pick this one group, I got to use them again, and then maybe I'll use your right arm for the second sample. You know what I'm saying? Or if I pick siblings, and I pick you guys as my first sample, then I have to pick your siblings for the second sample. Right? Because you have to be matched up. So if I pick Brandon, for my first one, I have to pick Brandon's sibling for the second sample. They've got to match up. Good? All right. Simple random samples. So the first group has to be randomly selected. The second part will be dependent upon the first sample. Does that make sense to you? Okay. And then the last one, either my n has to be larger than 30 or the data has to be normally distributed. So pretty much, I'm not going to give you something larger than 30. That's ridiculous on a test. I'm going to say, assume the data is normally distributed. All right. The only other change is, so this is totally the same, right? For your test stat, you take your x bar minus the mean over s over square root of n, right? You guys have seen that? Right, where d bar is really x bar sub d. What you can kind of think of it that way. This is the same as this is really x bar sub d of your d's. But here's the catch. It's even simpler for this one. For two sample dependent, we're always assuming that the difference is 0. So we're going to assume that this is 0. So it's even easier. It's always going to be d bar. The difference is 0. That affects your H naught. So so maybe somewhere on your notes you're going to have to put in, because it's not on the sheet here. You got to add into your notes somewhere that for a two sample dependent means, use the one sample t-test on your differences and use mu naught equals 0. So that's what I would do. I'll say it one more time. For a two sample dependent mean test, use the one sample mean test In other words, use this guy right here, one sample test, this one right here, with mu naught equal to 0. Mu naught equal to 0. So, I'm not gonna worry about that. Alright, so let's go ahead and look at the example we have. Right, I found all the differences. These are my little d's down here. And I need to find their mean and standard deviation. How would I do that?
Oh, sorry.
Throw them in your calculator. Right? Let me clear mine. So everyone get your calculators out. Okay. So I'm gonna go to stat, edit. I'm gonna throw these guys into my list. 19, negative 12. Remember, if you're doing negative, you gotta use this little number down here at the bottom next to the enter as your negative. Negative 12, 8, 0, 1. And then I'm gonna do stat, calc, 1 bar stats, and it's in list 1, so I just hit enter, and it'll give it to me. Or I can hit second list 1, second L1 if I want. And that gives me my X bar and my S. Remember, this is a sample, so don't use sigma, this is a sample, so use S. That's our sample standard deviation. So my S is 11.4, and my X is, right, and my X bar is 3.2. So X bar is 3.2, and my S is 11.4. Great. Now, our first step is that it's all about mu d. So this one's weird. It's totally different than the other ones. Mu d is equal to 0. It's always going to be your dependent one. The difference is because you don't no longer have 2 samples. You've subtracted them to get 1 sample. It's just 1 sample. Very straightforward. So that sample of the differences, the d's, your mu d is going to be equal to 0. In this case, we said that we think that the first group is higher than the second group. So we think that the differences are going to be positive, bigger than 0. We're saying mu1 is larger than mu2. Their differences are going to be greater than 0. If we'd said that mu1 is less than mu2, then we'd say that their differences are less than 0. If we'd said that they're the same, we'd say that the differences is equal to 0. Does everyone understand those how that works? That's a little twist. Okay, good. So this is our claim. Sorry, this should be H1. Total there. So this is my claim, which means that I'm going to use the word support later on.
So this is also doing 5 steps?
This is my first step. Yep. Second step. I just want to say second step, playing the guitar for Tom's. Right. It's from miscongeniality. Forget it. All right. So the critical value is, I'm looking up on the table. Let's see, how many did I have? I had 5 things here. Is that right?
Uh-huh.
So my degrees of freedom is going to be 5 minus 1. So that's 4. And what was my alpha?
0.05.
Alpha is 0.05. I'm one-tailed. Am I right-tailed or left-tailed? Right-tailed?
Right.
So it's going to be positive. I'm going to shade. And one-tailed, degrees of freedom 4. I'm going to pull out my T-table here. Alpha one-tailed, 0.05, degrees of freedom 4, 2.132. Great. Is that right? Okay. 2.132. Terrific. Now, next step. Step 3. I'm going to find my test stat. So it's going to be my mean, 3.2, minus 0, so I'm going to leave it alone, over my S, 11.4, over square root of n, square root of 5. If I do that, I will get 0.0628. Or 0.628. So I'm gonna throw that in here. So please note, here's my middle. Put it somewhere on the same side. You don't throw it over here somewhere. 0.62. Is that in the guilty range or not guilty range? Yeah, totally not guilty. So do not reject H naught. And then my step 5 will be not enough evidence. Remember, step 5, there's only 2 parts to number 5. The first part is either you have enough evidence or you don't have enough evidence. That's based entirely upon whether or not I reject it, whether it's in the guilty range or not guilty range. Right, guilty is way out there. If it's unusual, really unusual, then you have enough evidence. We did not have enough evidence. So, not enough evidence. And the second part is going to be to support or reject, either support or reject. If my H naught's my claim, it's going to be reject. If H1's my claim, it's going to be support. So what was my claim? H1, so support. Claim, and then paraphrase the claim somehow. That presidents are taller than opponents. I feel like I did go over this part with other people, so I will go over it with you guys again. So I'm going to go over one more time with step 5. So who finds step 5 a little bit confusing? You guys are all pretty shape. I'll go over just one more time just to make sure you guys are really good. So really, step 5 again is all about your claim. We're only going to do, there's only 2 things that vary. The first part is either there is or is not sufficient evidence. The second thing that varies is either the word reject or support. So the sufficient evidence depends entirely upon step 4. If it's in the guilty range, you have enough evidence. If it isn't, then if it's in the middle, right, then you do not have enough evidence. This part here is if H naught's your claim, you're going to use the word reject. If H1's your claim, you're going to use the word support. Yeah.
So in the last example, how would you say if the claim was H naught instead of H1?
We would say not enough evidence to support, to reject the claim.
To reject.
If H naught wasn't the claim.
Oh,
Not enough evidence to reject the claim that they're equal.
Yeah. Makes sense.
And again, the way to remember this is to have that little QRS, right? Q kind of starts you off. R is rejects. It goes when H naught is your claim. S is for supports. It goes when H1 is your claim. This part here, you're always going to reject H naught or not reject H naught. Always. Either going to reject it or not reject it. That's step 4. But if H1 is your claim, then doing this supports your claim. If H naught is your claim, then rejecting H naught rejects your claim. That's why you use those words. You don't have to fully understand that if you don't want to. You could stick with the fact that what comes first, R or S? R. What comes first? H naught or H1? H naught. So H naught goes with R, rejects. And H1 goes with S, supports.
And I accept my Q as a question.
Oh, good. Q is question. Q is the question.
The question is,
Nice.
was H not?
I like that.
Oh, nice. Nice work.
There you go.
Oh, is that the gender reveal?
The blue. And they're like, yeah,
Alright, so you guys have one to do. Do it.
You heard what I said.